In this problem, you apply a torque onto a solid disk. The mass of the disk, you need to find it out with the information of the torque and the radius, and also tells you about the angular acceleration. Okay, with all this information, you should be able to find it out the mass of the disk. Let's do it here. So you have a disk. A disk is given here, and a torque is applied here, a force. Then this force causes is or let's say torque. So torque, when you apply torque, it starts spinning about its axis. The torque, the given information, the torque is 12 Newton, 12 Newton meter. Okay, and the radius is given as 0.5 meter, and this acceleration is the angular acceleration, which is denoted by alpha. This is called the angular acceleration. This information is given, which is 5.7 radian per second square, and you need to find out what is the mass of the disk. So you, in translational motion, in a linear motion, the force is equal to mass times acceleration. And if you go into the rotational motion, the same formula now becomes torque. Instead of mass, it becomes the moment of inertia. Instead of linear acceleration, it becomes angular acceleration. Torque is I times alpha. Okay? Now, the torque mass, the I is the moment of inertia of the disk, and the moment of inertia of the disk is given by half mr squared. Okay, so this is the moment of inertia of the disk. So just plug in the value here, half mr squared times alpha, and you need to find out the mass. So the mass can be, the solid for the mass is 2 times torque divided by r squared times alpha. Let's plug in all the numbers here. 2, the torque value is 12, radius is 0.5, and the angular acceleration is 5.7. So once you solve this one, the mass you will get is 16.84.